Hey there, universe nerds. Today we're heading into one of the strangest and most extreme realms in the cosmos, the world of neutron stars. These are the collapsed hearts of giant stars, the leftovers after a supernova explosion. They're tiny, about the size of a city, but so dense that a single teaspoon of neutron star material would weigh as much as Mount Everest. They're magnetic, fast-spinning, and sometimes so powerful they beam energy across the galaxy. If black holes are the monsters of the universe, the neutron stars are their ferocious little cousins, smaller but just as awe-inspiring. Let's start at the beginning. A neutron star forms when a massive star, at least 8 times the mass of our Sun, runs out of fuel. When fusion stops, the outward pressure that kept the star stable collapses. The core implodes under its own gravity, smashing protons and electrons together to form neutrons. The outer layers rebound and explode outward in a supernova, while the collapsed core remains behind, now just 20 kilometers across, but packed with more mass than the Sun. The result is a neutron star, one of nature's densest and most extreme creations. Inside a neutron star, matter behaves in ways we can barely imagine. The surface crust is made of atomic nuclei squeezed into a crystalline lattice. Below that, the pressure is so immense that atoms themselves can't exist. Electrons merge with protons to form neutrons, and deeper still, those neutrons may even break down into a soup of quarks and exotic particles. We don't fully know what happens inside. It's a frontier of physics where the rules of quantum mechanics and relativity collide head-on. One of the most astonishing things about neutron stars is how fast they spin. Because of angular momentum, the same principle that makes a figure skater spin faster when pulling in their arms, a collapsing star spins up dramatically. Some neutron stars rotate hundreds of times per second. These fast rotators, called pulsars, shoot beams of radio waves or X-rays from their magnetic poles. As they spin, those beams sweep across the sky like cosmic lighthouses. When the beam points toward Earth, we detect a pulse, hence the name. Pulsars are so precise that scientists use them as cosmic clocks to test the laws of physics. The first pulsar was discovered in 1967 by Jocelyn Bell Burnell, who noticed a repeating radio signal that seemed too regular to be natural. For a brief moment, the team nicknamed it LGM-1, short for Little Green Men, before realizing it was something far more profound. That discovery opened a new era in astrophysics, revealing not aliens, but one of the universe's strangest kinds of stars. Since then, thousands of pulsars have been found, each one spinning steadily across time and space. Neutron stars also have insanely strong magnetic fields, up to a quadrillion times stronger than Earth's. These supermagnetic versions, known as magnetars, can unleash bursts of energy that outshine entire galaxies for brief moments. When their magnetic fields twist and snap, they produce gamma-ray flares so intense that they could fry satellites from halfway across the solar system. Scientists think magnetars might even be responsible for some mysterious fast radio bursts we've observed in deep space. Even though neutron stars are small, they have a huge gravitational pull. If you stood on one, not that you could, gravity would be about 200 billion times stronger than on Earth. You wouldn't just be flattened, you'd be crushed smaller than a molecule in an instant. Time itself would slow dramatically near the surface because of intense gravity. And yet, despite their deadly nature, neutron stars are also incredibly beautiful, glowing in X-rays, spinning like cosmic tops, and holding secrets about the fundamental forces of nature. When two neutron stars collide, the result is one of the most violent events in the universe. The impact releases gravitational waves, ripples in spacetime that detectors like LIGO and Virgo can actually hear. The famous event GW 170817 in 2017 was the first time scientists observed both gravitational waves and light from a neutron star merger. That explosion also produced heavy elements like gold and platinum, proving that many of the precious metals on Earth were forged in these cosmic collisions. The next time you wear gold jewelry, remember, it was born in the crash of two dead stars. Neutron stars are not just remnants, they're laboratories for extreme physics. By studying them, scientists test theories about quantum matter, nuclear density, and relativity. Future observatories like the Square Kilometer Array and the NICER mission on the ISS are helping us peer deeper into their mysteries, measuring their mass, radius, and structure with incredible precision. Each discovery pushes the boundary of what we know about matter, gravity, and the limits of physics. So what are neutron stars? They're the tiny, terrifying hearts of dead giants, stars crushed into nuclear matter, spinning, glowing, and sometimes screaming across the galaxy. They defy the imagination, compressing entire suns into something you could walk around in half an hour if it didn't vaporize you instantly. They're proof that the universe doesn't just create, it compresses, recycles, and reinvents. And in every flash from a pulsar, every gravitational wave, we hear the heartbeat of a cosmos that still has much to teach us.